Alright, this is how I'm going to teach the lessons. I have my phone propped up so you can see my paper, and I'll still have my same pens. Can't teach without those. So I will do the lessons on here. You can take the notes just like you do in class. The difference is now you will be doing the homework on the computer because you'll be doing it in my math lab. Alright, so 4.1 is exponential functions, and I'm actually going to start with checkpoint 2 and checkpoint 3. This is all getting you ready to do logs. So before you do logs, you generally do exponential functions. So for this one, we are going to graph an exponential. All right, we have f of x equals 3 to the x. So to do this, I'm actually just going to make a table of values. I'm going to put in -2, -1, 0, 1, and 2. So anything to the 0 power is 1, 3 to the 1 is 3, 3 to the 2 is 9. Now the negatives will be that flipped over. So 3 to the -1 is 1/3, 3 to the -2, flip it, square the 3, it becomes 1/9. Then I'm just going to plot all those points, -2, 1/9, -1, 1/3, 0, 1, 1, 3, and then 2, 9 would be way up there. So you'll see it does kind of slip up like that. There is an asymptote. You don't find it the same way we do with the others. But in this case, the x-axis is the asymptote. So it has an asymptote at y equals 0. And we'll be shifting this and all that kind of stuff, but not quite yet. All right, checkpoint 2 is a problem that goes right with this. Or, sorry, checkpoint 3. This is also graphing an exponential. For this one, we're going to graph, actually it has f of x equals 1/3 to the x. So very similar to the one we just did, except instead of the 3, you have a 1/3. Let's see what it does to the graph. I'm going to do it the same way. I'm going to do a table, and I'm going to do a table of values. Same values for x, -2, -1, 0, 1, and 2. Anything to the 0 is 1. 1/3 to the 1 would be 1/3. 1/3 to the second would be 1/9. So what happens when we flip this, 1/3 to the -1, it would become 3. 1/3 to the -2 would flip and become 9. So we have -2, 9. And it's way up there. -1, 3. 0, 1. 1, 1/3. And 2, 1/9. And so it does the same thing. It also has an asymptote at y equals 0. It just goes in the opposite direction. It's falling instead of rising. All right, so all those rules we used before with the shifting and all that is going to apply here as well. So real quick, I'm going to go through the transformations with the exponentials. Okay, so our parent in this case will just be f of x equals b to the x. And the same way I did in section 2.5, where we kind of did it one thing at a time, and I did it in order, I'm going to do the same thing here. So the first thing you would do is your horizontal shifts. This is something inside the function. So if we have b to the x as our parent, you can have g of x equals b to the x plus c, where it's up in the exponent, or g of x equals b to the x minus c. So remember, horizontal shifts do opposite. So this shifts f of x left c units. This one shifts f of x right c units. All right, so that's horizontal. The next thing you would do are your reflections, or your flips. This is your negative, either inside or outside the function. So g of x equals b to the negative x, or g of x equals negative b to the x. Remember I had that stupid thing, that whole inside-outside thing? So this negative is inside the function. So you have y-axis, inside is y-axis. This is outside the function, so you have the x's and o's over the x-axis. It's dumb, but hey, maybe it worked for somebody. So this flips f of x over the y-axis. This flips f of x over the x-axis. All right, and then last but not least, you have your vertical shift. And this is the only one to me that makes any sense because it does what you think it's going to do. This is your ups and downs. And remember, you add or subtract something outside the function. So you could have g of x equals b to the x and then plus c down on the ground. Or g of x equals b to the x and minus c down on the ground. So plus c means you're going up c units. And minus c means you're shifting f of x down c units. All right, we have a couple checkpoints to go with this. So checkpoint 4, we have to use the graph of f of x equals 3 to the x from that we had used before, we had graphed before, and we're going to shift it. Okay, it's graphing with transformations. Okay, we're going to use f of x equals 3 to the x to graph, and that's the one we had done before. G of x equals 3 to the x minus 1. Okay. Okay, so 3 to the x we had done before. I'm going to do this real quick, or you can look at your other one. So 1/9, 1/3, 1/3, 3, 9. Okay, and then we plot those points. 9's probably not happening. Just didn't leave enough space. Okay, so that's the original f of x. Now 3 to the x minus 1. It's got a minus 1 up in the exponent. So that means we're going to go right c units, or 1 unit, sorry. So I only plotted 4 of the points. So each of my 4 points will go to the right 1 unit. And when we're doing this, the asymptote will actually stay the same. When you shift to the right, the asymptote stays at y equals 0. Okay, so both of them have an asymptote at y equals 0. Now let's look at checkpoint 5. And these you're mostly just going to have, it's not like 2.5 where you had a bunch of things to do with each one. This one, you just mostly just have one thing to do on each one. Alright, so checkpoint 5. Again, we're graphing with transformations. We're going to use f of x equals 2 to the x this time, so a different one, to graph g of x equals 2 to the x, and then plus 1 down on the ground. Alright, so 2 to the x this time. Oops, let me put a graph there. Okay, so anything to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4. So 2 to the negative 1 would flip it and make it 1/2. 2 to the negative 2 would flip it and make it 1/4. So we have negative 2, 1/4. We have negative 1, 1/2. 0, 1. 1, 2. And 2, 4. Alright, so that's our original graph, 2 to the x. Now we've got a plus 1 for the other one. So that plus 1 is going to shift it up 1. So we're going to shift our original f of x up 1 unit. Every point up 1 unit. This time I was able to get all 5 in there. This will change our asymptote. So we now have an asymptote at y equals 1. That's supposed to be an abbreviation. The original had an asymptote at y equals 0. Alright, so that's just some light shifting with the exponentials. We won't get too into it. You are going to have to graph logs, and that's actually what you need this for more than anything. You're also going to have to solve, like, checkpoint 6 is a word problem. Now here's the tricky thing. I am teaching from your book, which is the 4th edition. If I knew we were going to have to switch to 5th, I would have grabbed my 5th edition book. but I didn't know that was going to happen. So if this word problem doesn't match exactly, I know it's the same type of problem. If you're looking at the book in my courses, you might see something a little bit different. It's never very different at all, though. Okay, so you're given an equation, f of x equals 1066 e to the 0.042x. All right, it says the exponential function f of x equals 1066 e to the 0.042x models the gray wolf population of the western Great Lakes. F of x, x years after 1978. So x years after 1978. If trends shown in the figure continue, project the gray wolf's population in the recovery area in 2012. All right, so in 2012, x would equal whatever 2012 minus 1978 is. Since I'm doing all these from scratch. You have 34. All right, so we need to figure out what f of 34 is. And really, this is making sure you can type this stuff in your calculator. So 1066e to the 0.042 times 34. And you can actually put that whole thing just in your calculator. Oops, not a graph. Okay, so 1066 second e to the 0.042 times 34. And I know some of you may be having to use your cell phones. Yeah, I didn't know if that parenthesis was going to matter. Or whatever for your calculator because you don't have access. Just find something that works. When it comes to your quiz, you're going to have the same, like I'm not going to take your cell phone away from you. And when it comes to your test, you're going to be able to use your cell phone as well. So there's a good scientific calculator on your scientific or on your phone. You might just have to use that. If you can download a graphing calculator, awesome. But I know when I upgraded my phone, I couldn't. So what's the question? Project the wolf population. So the wolf population is approximately 4,446 wolves. Oops. Wolf is... Okay. Alright, so that's just making sure you know where E is on your calculator. Like I said, if you're using your cell phone, I can't show you on my cell phone because that's what I'm using to record. I'm not using Zoom or anything like that. Just make sure you know how to put it in, basically. All right, and then the last thing we need to learn is the money equations, the interest problems. So we're going to have compounding continuously or compounding at a specific set of time. All right, so formulas for compound interest. All right, you have two formulas. First one, A equals P times 1 plus R over N to the NT. And then A equals PERT, PE to the RT. Remember, RT is an exponent. So for all of these, or for both of these, or wait, hang on, before I do that. This is for N compounds per year. And then the other one is for continuous compounding. All right, in both of these you have an A. A is the accumulated amount, or the amount in the end. Both of these have a P. P is the beginning principal, or the amount in the beginning. R is your interest rate. It's usually given as a percent. Change it to a decimal. And then T is the number of years. Okay, the E is the E. So that's just like your E in the calculator. Now the thing that is a little bit different is then the first one has an N. And N will be your number of compounds per year. So this one is not in PERT. Okay, so if it's annually, N is 1. If it's biannually, N is 2. If it's quarterly, N is 4. If it's monthly, N is 12. Okay, so there's others, but those are the most frequent. All right, so checkpoint 7. This is using your interest formulas. All right, it says a sum of $10,000 is invested at an annual rate of 8%. Find the balance in the account after 5 years, subject to A, quarterly compounding, and B, continuously compounding. Okay, so we have some things that are common for both. We have $10,000 being invested. So for both of these, our P is 10,000. An annual rate of 8%. So for both of these, our R is 8%. Which if you move the decimal back 2 spaces, R would be 0.08. And we're doing it after 5 years. So in both cases, T is 5. All right, now those are statistics for both. Now for A, it says quarterly compounding. So that means for A, we use A equals P times 1 plus R over N to the NT. And then it's quarterly compounding, so N will be 4. For B, we're going to use A equals PE to the RT. We don't need anything additional on that one. So you just get everything plugged in and it basically becomes a calculator problem. So we have 10,000 times 1 plus 0.08 over 4 to the 4 times 5. Okay. So if I do 0.08 divided by 4 first, Then I add 1 to it. That becomes 1.02. So we have 10,000 times 1.02 to the 20th. So next, take 1.02 to the 20th. If this is a crazy decimal, don't clear it. So just to the 20th, or 4 times 5. And then I'm going to multiply that times 10,000. And there's my ending amount. So that's $14,859.47. It's money, so I'm going to round it like money. All right, and then we have A equals PE to the RT. So we have 10,000 times E to the 0.08 times 5. The nice thing about this one is you can pretty much just throw the whole thing in there. So 10,000. Sorry. I have to do these after my kids go to bed because they're crazy. All right, so we have 10,000 E to the 0.08 times 5. Close the parentheses or whatever. There's your answer. So 14,000, round it like money again. $14,918.25. Okay. All right, if you have any questions, feel free to contact me through Teams or email. I'll be checking them both between the hours of 8:30 and 9. You do need to do, I would suggest writing all these notes out and then doing your homework inside of my courses. You can have unlimited attempts. So you can keep going until you get 100%. Let me know if you have any problems.